Let us do some important objective questions on chemical bond. We'll be talking about various types of bonding, hybridization, Vesper theory, dipole moment and all. Let's look at question number 1. Which one of the following compounds does not follow octet rule? The options are number 1 carbon dioxide, number 2 PCl3, number 3 ICl and number 4 ClF3. Let's find out. This is CO2. The central atom carbon is surrounded by 4 bond pairs, so it is octet. And the surrounding atom oxygen is having 2 lone pairs and 2 bond pairs, so it is also having octet configuration. So CO2 is obeying octet rule. Look at PCl3. PCl3 consists of a lone pair on phosphorus and it has got 3 bond pairs with 3 chlorine atoms. This is also obeying octet rule. 1 lone pair and 3 bond pairs. Total 4 pairs. 4 pairs means 8 electrons. ICl. There is 1 bond pair and 3 lone pairs on each halogen. So this is also obeying octet rule. Now the last example, ClF3. The central atom chlorine has got 2 lone pairs and 3 bond pairs. So it has 5 pairs of electrons, which comes to 10 electrons. So this is violating octet rule. So this is not following octet rule. So the correct answer is 4th option, ClF3. Question number 2. Which of the following has maximum ionic character? Which one of the following has maximum ionic character? See, according to Fajan's rules, for greater ionic character, the extent of polarization should be less. For greater ionic character, the extent of polarization should be less. So you require large cation and small anion. So if you see the options, the compound which has largest cation is cesium fluoride. It has largest cation and smallest anion. So the correct answer is 3rd option. CSF is most ionic among them. It is because of very small anion and very large cation. Question number 3. In which one of the following compounds the sigma bonds are not equal to pi bonds? Option 1 tetracyanoethylene. Let's look at the structure. This is the structure of tetracyanoethylene. You know, in a multiple bond there are pi bonds. In a triple bond you have 2 pi bonds and 1 sigma bond. In a double bond you have 1 sigma and 1 pi bond. So number of sigma bonds are 1, 2, 3, 4, 5, 6, 7, 8, 9. Sigma bonds are 9. Pi bonds are 2 plus 2 4, 5, 5 plus 2 7, plus 2 9. So tetracyanoethylene has equal number of sigma and pi bonds. Let's see tetracyanomethane. If you count 1, 2, 3, 4, 5, 6, 7, 8. 8 sigma bonds. Pi bonds 2 plus 2 plus 2 plus 2, 8. So even this has equal number of sigma and pi bonds. Now let's look at carbon dioxide. Carbon dioxide has 2 sigma bonds and 2 pi bonds, one this side and one this side. And acetylene, sigma bonds are 3 in number, pi bonds are only 2. So this is the answer. It does not have equal number of sigma and pi bond. So the correct answer is 4th option, acetylene. Question number 4. Which of the following molecules is polar? Let's see. First option, carbon dioxide. It is non-polar because of linear molecule and it is symmetric. So the bond polarity due to this will be cancelled out by this non-polar molecule. BF3. BF3 has a plain triangular shape. Mu equals to 0. Here also mu equals to 0. And then you have CCl4. CCl4 has a regular tetrahedral shape, so mu equals to 0. SnCl2 is angular, so mu is not equal to 0. So the polar molecule among them is stannous chloride. Question number 5. In PCl3 to PCl5 transformation, the hybridization of phosphorus changes to first option sp2 to sp3, second option sp3 to sp2, third option sp3 to sp3d, and fourth option is sp3 to dsp2. Let's look. The hybridization of phosphorus in PCl3 is sp3. It has got one lone pair. Because it has got one lone pair and 3 bond pairs, it requires 4 hybrid orbitals, so hybridization is sp3. This has 5 bond pairs. Therefore, it requires 5 hybrid orbitals and the hybridization is sp3d. So the correct answer is third option, sp3 in PCl3 to sp3d in PCl5. Question number 6. The molecule having distorted tetrahedral structure is first option SiH4, it is symmetrically surrounded by identical atoms, therefore it is regular. It is a regular tetrahedral. It has a regular tetrahedral shape. Same is the case with CCl4. It is symmetrically surrounded by 4 identical chlorines, so it is also regular tetrahedral. And then water, bent shape. Then chloroform. This is chloroform. This is distorted. I'll tell you why it is distorted. One bond is CH bond, the other 3 bonds are CCl bonds. So there is a difference in the nature of bonds, so that makes it distorted. It will not have a regular shape, it will be distorted tetrahedral shape. So the correct answer is fourth option. Question number 7. The molecule having highest boiling point is, the first option is propanoic acid, second option is propanol, third option is ether, and fourth option is a ketone. Among these compounds, extensive hydrogen bonding is possible in propanoic acid. So propanoic acid, due to extensive hydrogen bonding, strong hydrogen bonding, its boiling point will be high. So the answer is first option. Question number 8. Which one of the following molecules is non-polar but contains polar bonds in it? Look. BCl3, due to plain triangular shape, it is mu equals to 0, but the bond is polar. BCl bond is polar because of difference in electronegativity of boron and chlorine. Look at the case of hydrogen, it has HH bond, which is a bond between identical atoms, therefore non-polar. Ammonia has polar bonds and molecule is also polar. Bond is also polar. And then chloroform, same is the case with chloroform. Chloroform molecule is polar, mu is not equal to 0, and the bonds are also polar. So the correct answer is BCl3. The overall molecule is non-polar, but the bonds present in the molecule are polar. First option. Question number 9. Which one of the following does not exhibit paramagnetism? In other words, which of these is diamagnetic? First option O2. it is paramagnetic. It has two unpaired electrons, pi star 2p x1, pi star 2p y1. These are the two unpaired electrons which make it paramagnetic. In O2 plus, you have one electron less. This is also paramagnetic, but the configuration is pi star 2p x1, pi star 2py 0. 0 because you have removed that electron. O2 has become O2 plus. Next, number 3, O2 minus. This is also paramagnetic. What happens here is one of these electrons will get paired up. So it becomes pi star 2p x2, pi star 2p y1. Then O2 2 minus. O2 2 minus, you have two extra electrons when compared to this. Both these electrons will get paired up. So it is pi star 2p x2, pi star 2p y2. So it is diamagnetic. So the correct answer is fourth option, O2 2 minus. Peroxide is diamagnetic. Question number 10. In which of the following pairs the two species are isostructural? Isostructural means having same structure. That is the meaning of isostructural. Options are BrO3 minus and XeO3. This has pyramidal arrangement. Same is the case with XeO3. XeO3 also has got a lone pair and 3 surrounding oxygens. So these two are pyramidal. Both are pyramidal. So they are isostructural. BrO3 and XeO3 are isostructural. But look at the case of this SF4. SF4 is seesaw and XeF4 is square planar. So they are not isostructural. Number 3, SO3 2 minus. This is pyramidal and NO3 minus is trigonal planar. The fourth option, BF3 and NF3. BF3 is trigonal planar and NF3 is just like ammonia. NF3 is pyramidal. So the correct answer is first option. Both XeO3 and BrO3 have pyramidal structure. They are isostructural. Answer is first option. Question number 11. NN bond distance is maximum in. See, first option is N2O3, second option N2O, third option N2O4 and fourth option is NO2. Fourth option is ruled out because it consists of only one nitrogen. So we have to decide between 1, 2 and 3. We decide on the basis of oxidation state and as well as bond order. See, N2O3 looks like this. It has an unsymmetrical structure like this. This is N2O. Obviously this is shorter than this because this is a single bond, this is a triple bond. N2O4. Forget about fourth option and NO2 because it has got only one nitrogen. Now oxidation state of this nitrogen is +3, this is +2. Here both are +4. So as the oxidation state increases, size decreases. When the size decreases, bond length decreases. So this is shorter, this is shortest, this is longest. So the correct answer is first option N2O3. Question number 12. AlCl3 is covalent while AlF3 is ionic. AlCl3 is covalent, AlF3 is ionic. AlCl3 is covalent while AlF3 is ionic. This fact can be justified on the basis of, we justify this on the basis of Fajans rules. Look at the options. First option is valence bond theory, second option is crystal structure, third option is lattice enthalpy, and fourth option is Fajans rule. The correct answer is Fajans rule. Actually, due to very small size of F, the extent of polarization caused by Al3 plus will be less, so AlF3 is more ionic. So decide on the basis of Fajans rules, fourth option. Question number 13. The bond order of superoxide N is first option 2.5, second option 2, third option 1.5, and fourth option is 1. See, O2 bond order is 2. Superoxide is O2 minus. So it has got one extra electron. When compared to O2, that extra electron goes to antibonding, so bond order decreases. So bond order will be, each electron entering into antibonding will decrease bond order by half unit. So this will become 1.5. So the correct answer is third option, 1.5. Question number 14. Which one of the following substances has the highest lattice enthalpy? See, look at the options. First option NaCl, second option CaCl2, third option MgO, fourth option is BaO. Lattice enthalpy depends upon the size of the cation and size of the anion. Of course, it depends on the magnitude of charge also. If you consider size and charge, the smallest size and highest charge is there in magnesium oxide, MgO, Mg2 plus and O2 minus attract each other very strongly because of their small size and high charge. So the correct answer is third option, MgO. Question number 15. In which one of the following pairs of molecules the two species have identical shape but differ in hybridization? Shape is identical but hybridization are different. Let's see. First option, ammonia is pyramidal and BF3 is trigonal planar. So shapes are different. So this answer is ruled out. Second option, XeF2 is linear with xenon in sp3d hybridization. BeCl2 is also linear, but beryllium is in sp hybridization. So shape is same but hybridizations are different. That is what we wanted. So answer is second option, but let's look at third option also. This is the answer. Third option, XeF2 I3 minus. Both are linear and in both the cases hybridization is sp3d. Fourth option, NH4 plus is tetrahedral and SF4 is seesaw. Shapes are different. So the correct answer is second option. Question number 16. In which one of the following bond angle is maximum? First option is ammonia. Due to lone pair, the bond angle is 107 degrees. Second option is NH4 plus. There is no lone pair, 4 bond pairs are there. Bond angle is 109 degrees, 28 minutes. PCl3. Bond angle is due to large size of phosphorus, the bond angle is lesser. SCl2. This is also less than 109 degrees 28 minutes because of 2 lone pairs on sulfur. This has got 1 lone pair, this has got 2 lone pairs. So the correct answer is second option. In ammonia, the bond angle is exact tetrahedral angle 109 degrees 28 minutes. Question 17. Which one of the following is not linear? Look at the options: BeCl2, second option CO2, third option acetylene, fourth option water. The correct answer is fourth option water. It is angular. Let's look at these structures. This is BeCl2, it's a linear molecule. Next CO2, it is also a linear molecule. Then you have C2H2, due to sp hybridization this is also linear. Water is bent shape or angular. So answer is fourth option. This is non-linear. Question 18. Which one of the following has a dipole moment? First option CS2, second option CCl2F2, third option SO3, fourth option SnCl4. Look, CS2 is a linear molecule and therefore mu is equal to 0, non-polar, no dipole moment. Then you have CCl2F2, mu is not equal to 0. This is a polar molecule. Third option is SO3. SO3 is also, the bond polarity is there, but the bond moments cancel out each other. Mu equals to 0 due to trigonal planar shape. And then number 4 is SnCl4. This has a tetrahedral arrangement of 4 chlorine atoms. All are identical atoms. There are non-identical atoms in this. That's why it is polar. All the atoms are identical and they cancel out each other, and therefore this is 0, non-polar molecule. Answer is second option. Question 19. The order of decreasing CC bond lengths in the following molecules. C2H4, this is C2H4, bond length is 1.34 angstroms. Then you have C2H2, bond length is 1.2 angstroms. Then you have benzene, 1.39 angstroms because the bond order is 1.5. And then ethane, bond angle is 1.54 angstroms because it's a single bond. So bond length depends upon bond order. As the bond order increases, bond length decreases. So the correct answer is first option. 4 is maximum and 2 is minimum. Question number 20. Which one of the following atomic orbitals are always involved in sigma bonding only? First option S orbital, second option p orbital, third option d orbital, and fourth option is f orbital. And the correct answer is S orbital. Because of its spherical shape, it cannot undergo lateral overlap. It can undergo only end-on or side-on overlap. So S orbitals always form sigma bond. So the correct answer is first option.